Hello everyone, welcome to Lecture 13 of the ISC2 Certified in Cybersecurity Examination Preparation Series. This lecture covers the OSI model in depth. So our agenda is to gain a knowledge of the overview of the OSI model, detailed discussion of each of the 7 layers, comparison with the TCP/IP model. Introduction to the OSI model. A layered network model standardizing communication functions in telecommunication or computing systems. Purpose is to ensure interoperability of diverse communication systems. OSI module has 7 abstraction layers. Mnemonic devices. 7 to 1. All people seem to need data processing. 1 to 7. Please do not throw sausage pizza away. These are some of the mnemonics to remember the 7 layers names. Layer 1. Physical layer. The function of the physical layer is to handle transmission of raw bit streams over a physical medium. Components: wires, fiber, radio waves, hubs, NIC parts, connectors, etc. Cable type: copper twisted pair, least secure, it is susceptible to interference and eavesdropping. Optical fiber: more secure, it is not susceptible to eavesdropping, but it incurs higher cost and it is harder to install. There are some topologies, there is bus topology, star topology, ring, and mesh topology. Threats. Threats to the layer 1 is data emanation, theft, eavesdropping, sniffing, and interference. Layer 2 or the data link layer. The function of the data link layer is to transport the data between two nodes on the same network. Components: LLC, logical link control, for error detection. MAC, unique hardware identifiers, ARP, for layer 2 by 3 address mapping. Protocols: CSMA or CD for Ethernet, CSMA or CA for wireless. Token passing obsolete. Threats. The threats include MAC spoofing, MAC flooding. Layer 3, the network layer. Function of layer 3 is to manage the routing of data between different nodes across multiple networks. Components: IP addresses, isolation into broadcast domains. Protocols: IP, ICMP, IPsec, IGMP, IGRP, IKE, ISAKMP, IPX. Threats. Threats include ping of death, ping floods, Smurf attacks, IP modifications, DHCP attacks. Layer 4, transport layer. Transport layer functions to ensure reliability, data transfer with error detection and recovery. Protocols. Some of the protocols of layer 4 are UDP, or the User Datagram Protocol. It is connectionless and is used for real-time applications, example VoIP, live video, gaming, etc. TCP, Transmission Control Protocol. It is reliable, connection-oriented, ensures guaranteed delivery. Threats: UDP, Fragile Attack, TCP, SYN floods. Layer 5 or the session layer. Functions: manages sessions between applications including setup, maintenance and teardown of connections. Components: controls dialogue between devices, managing data exchange. Layer 6 or the presentation layer. The function of the presentation layer is to ensure that data is a usable format and is where data encryption occurs. Components: formatting, compressing and encrypting data. The only layer without specific protocols. Application layer. The function of the application layer is to provide network services to end user applications. Protocols of the application layer include the HTTP protocol, HTTPS protocol, FTP, SNMP, IMAP, and POP. Components: non-repudiation, certificates, application proxies, deep packet inspection, content inspection, AD integration, etc. Threats. Threats to layer 7 are viruses, worms, trojans, buffer overflow, application or OS vulnerabilities. PDU, protocol data units. PDUs for each layer. Layer 1 bits, Layer 2 frames, Layer 3 packets, Layer 4 segments, Layers 5 to 7 data. The OSI model summary. Each layer serves a specific function in the data communication process. The higher the layer, the slower but more intelligent the process. The TCP/IP model. A conceptual model providing end-to-end data communication, specifying how data is packetized, addressed, transmitted, routed, and received. Layers: link, internet, transport, and application. These are the types of layers in the TCP/IP model. Link layer. It corresponds to OSI layers 1 to 2. It manages the hardware, addressing, and network access. The internet layer. It corresponds to OSI layer 3. It handles routing and forwarding. Transport layer. It corresponds to OSI layer 4. It manages end-to-end communication. Application layer. It corresponds to OS layers 5 to 7. It provides protocols for specific data communication services on a process-to-process level. Comparing the OSI and TCP/IP models. OSI model, it is a 7-layer, more detailed conceptual model. TCP/IP model, it is 4 layers, practical and implementation focused. Encapsulation and decapsulation. Each of the OSI and TCP/IP models adds or removes headers as data passes through. This addition of data or headers is called encapsulation and the removal is called decapsulation. The key concept: higher layers add more intelligence and control to data processing, but at the cost of speed. Finally, we come to the conclusion of this lecture. We discussed the detail of each OSI layer and its function. We discussed comparison with the TCP/IP model. We laid emphasis on understanding the OSI model, which is a fundamental for grasping how network protocols interact and ensure reliable communication. Thank you and have a nice day.